Module 7, Section 2, Implementing IBC in Cosmos SDK. So now that we understand what IBC is and how it works, let's unlock the interoperability in our chain. So to do this, we're going to use this dependency. That's IBC Go. It's the Inter-Blockchain Communication Protocol implementation in Golang. But I have some news for you, some good and bad news. The bad news is that the latest version that it's released so far, the 8.3.1, it's not supporting dependency injection yet. So the bad news is that we'll have to refactor our code to wire it up without dependency injection. But the good news is that you will learn also how to wire an application without dependency injection, but using the old way. I'm not going to record all the procedure to the refactor, but we'll post a commit with the refactor. However, if by the time that you see this recording, there's already a version that it's supporting dependency injection, you can go ahead and use the same setup and wire that version using dependency injection. So in this way, you will not have to do all this refactor. Here I made the refactor to wire up our application using the old way. So you will see that there's much more code than when we're using the dependency injection. That's why one of the reasons why the SDK team added the dependency injection to reduce the size of this app.go file. But let's go real quick with the changes that I did. Basically, the changes include adding all the setup that the app.yaml had. You can see here, for example, we have the permits for the accounts. Now we have to define it in the code in Go. And this is the same that this, the module account permissions, where we set the different permissions for each of the modules. Then we have to add the keys to our application. Change here the runtime app for the base app, and defining also the module manager and the basic module manager, as well as the configurator. And here we replaced all the dependency injection code with this interface registry with options, where we set the beg32 prefix for our application and different setups like the version, the transaction encoded. Then we set the keys of all our stores. We create an instance of the RPS app, and then we start instantiating all the keepers that we need in our application. So you see we're just calling here the new keeper with the corresponding input parameters, and then instantiating a module manager where we pass all the modules that we have and the basic module manager, and then setting the order for pre-blockers, begin blockers. That's the same that we have here, the pre-blockers, begin blockers, and blockers. In Genesis, you are setting the order for each of the modules. As you can see here, we have define this order using the module names. So for now we can delete this app.yaml. We're not going to use it anymore. And after setting the order of the different IBCI functions, we have some validations and loading the latest version if there's any within our database. And also we have to define all these methods to comply with the corresponding interface. And that's pretty much it. We have something about auto CLI options. We have to wire them also manually, and some other helper functions for registering the routes, the transaction services, a Tendermint service. And that's pretty much all the changes that you have to do. If you ask yourself where you can get a reference of this or where do I get all this, if you go to either the IBC Go or the Cosmos SDK repo, they usually have an example of how to wire an application. You have to go, in the case of IBC Go, you have to go to the testing directory, and within that you will see this same app, that it is actually an application built for testing and educational purposes. So if you go to the app.go, you will get an idea of how to wire an application. In this case, also using all the IBC modules that we are going to add now, but you can use this also as a reference on how to wire your application. I also had to make a few changes in other files. In the export, I defined just this Genesis state that we needed. And also in the root.go, we had to make a few changes as well. Add this code for getting the client context, and then some small changes here on the transaction configuration options. And down here we also have this helper function, but that's pretty much it. Then also adding the keys to our module, adding a store key that we needed also for initializing our module in the app.go. But that's all the changes. And let's make sure that the application works as expected. We can check it here, make install to see if everything is working as before. We're going to start a new chain and run the tests. So first we can just run go tests for all the unit tests to see if we're passing. And now we can start a node and run our end-to-end tests. And while doing this, I noticed something interesting. If you go and run npm test, you will see that one of the transaction tests is failing because of the amount of events that the transaction emits. So that's something that if you want, you can debug and see what's going on. Maybe there's a bug within the Cosmos SDK and you can report it and find a fix. But if we check here what failed, you see there's expecting to have 5 events, as previously we had 5 events with the dependency injection, but now it is 2 events that we're receiving here, response events. So we'll edit this for now to have not to have length 0, so it has to have length for fixing this test, but it's something that ideally should not happen because for some reason we are having more events when using one way of wiring the app than when doing the old way. Let's restart the chain and try again the tests. And now all are passing. So we now are sure that this is working as before, so we can make a commit with the refactor. So let's first create a new branch, lesson 7, and add there the first commit. Refactor app wiring to the old way. Git push origin lesson 7. Now that we have everything set up in our app with old way of wiring the application, go ahead and go into the IBC Go repository and check the latest version. If you go here main, you can select the tag that you want, the B8.3.1. And as I mentioned before, you have here within the testing, the sim app and app.go file. And this is pretty much what we'll have to do to enable IBC. You will have here different applications that they are actually wiring. They're wiring also some interchain accounts functionalities as well. But for now, let's just focus on the transfer functionality. So you'll have to add all things related to IBC transfer. You see these imports that comes from module apps transfer. So now go ahead and try yourself enable IBC transfer on your application by just adding. You'll have to add the IBC transfer types, an IBC transfer module, and also the IBC exported, that it's the base IBC that it's needed for any of the applications. As you will see here, you have the IBC exported. You will need everything that it's within the modules core and everything that it's within the modules app transfer. For now, you can avoid adding all this fee and ICA stuff. So go ahead, go through this file and add all the missing pieces so we can enable IBC. Later on, I will show you which are the changes necessary. So if you don't want to do this, you will have this as a reference and a starting point for continuing our work.